Hey everyone, Eli Schilling here, Director of Product Management for Oracle Cloud. Welcome to Getting Started with Infrastructure as Code and Terraform. We're going to walk through some of the basics, some of the fundamentals of both infrastructure as code, what it is conceptually, and how to apply it through the use of Terraform. So let's get started. Now, as we previously talked about, why infrastructure as code? Well, the whole benefit here is being able to define the end state. We're declaring what we want as a result, and we're allowing the tool, in this case Terraform, to create and manage all of the resources to achieve that end state for us. This gives us self-documenting infrastructure, it gives us consistent and repeatable results, and it enables us to increase efficiency while potentially reducing and mitigating risks. If we're programmatizing our code, our infrastructure, we're allowing this tool to automatically provision and manage the infrastructure for us. It's going to reduce the potential for human error, the potential for unmitigated risks in our environment, and it allows us to simply and easily deploy, manage, and repeat with our infrastructure. Now, one of the fundamentals for infrastructure as code is making sure we have a good development environment. When I first started, I might have been using Notepad to write my Terraform, but you use something like Atom, A-T-O-M, use Visual Studio. It's going to give you some really good tools. It's going to format the code for you. It's going to give you basic validation, linting capabilities. Atom actually has some plugins you can add to autocomplete various Terraform configuration. So a lot of good ways to simplify and streamline writing, formatting, and managing your infrastructure as code with the right toolkit. Because this is code, we should treat it as such. I highly recommend that you store your Terraform configuration in source control, just like you would your application code. Use Git, use GitHub, use GitLab, use Bitbucket. Anywhere that you can securely store, control access to, audit, and manage and maintain your code effectively. That gives you the ability to identify when changes happen, who made the change, what the change actually was, and in a proper source control system, you can easily roll back unwanted changes to your code. Now let's start with Terraform configuration files. Terraform configuration can be one giant file, or it can be split up into multiple individual files. Sometimes what you'll find is people will take and they'll create a Terraform config file for each individual resource type they're creating. I'll have one for compute, one for network, one for storage perhaps, and all I do is put those in the same working directory, and when I run Terraform, it's going to look at all of the TF or TF-JSON files in that directory and aggregate them into a single working set and work to apply those in my environment. Now, by default, subfolders are not included. There is a mechanism we'll look at later called modules, where we can actually specify an alternate folder location, whether it's a subfolder or not, to go and grab additional Terraform configuration into our deployment. The files, although merged in alphabetical order, doesn't really matter the sequence in which you define your resources. Terraform is going to use all of the information available to identify the best possible sequence, or the most appropriate sequence, in which to provision those resources. Terraform will know that a VCN comes before a subnet, right? I have to have the virtual cloud network before I can create the subnet. So it will identify and string those dependencies together when creating your resources. Any file that's not .tf, .tf.json, .tf-vars will be completely ignored. Terraform's not going to try and interpret your Word docs, your Excel files, your JPEGs, etc. Now, a quick look at the Terraform config files. There's two valid options here. There's the human readable form. This is called HCL, or HashiCorp Config Language. It's very simple, easy to write, easy to read. Terraform also supports machine language, in this case JSON. So depending upon how you're constructing your Terraform config, it could be written using some sort of machine language or a tool that produces JSON, or if you're writing it by hand, you would use the HCL format. And as you can see here on the screen, the HCL and the JSON, They're going to produce the same output, but HCL is far more simplified. And again, it's the human readable format. Now, Terraform requires a provider to really make the magic happen. In this case, OCI has produced a provider that does all of the API interpretation for the third-party platform. Terraform actually supports over 70 different providers for cloud providers, on-prem software, various private cloud providers, etc. So you simply need to specify the provider that you plan to use, along with the necessary configuration elements like my OCI tenancy ID, my user OCID if I'm going to be authenticating with an IAM user, and of course the region where we plan to deploy or provision these resources. Alternatively, within OCI there is a concept of an instance principal, so I can allocate permissions to a compute resource. If I'm running something like Jenkins, and Jenkins is applying my Terraform configuration for me, or maybe I'm going to deploy Terraform Cloud onto a compute resource in my OCI environment, I can simply assign permissions to the server, and then Terraform can leverage that instance principal, which is essentially an ephemeral set of credentials, to authenticate to the OCI API endpoint. Now, getting started, we'll take a look at resource definition within our Terraform configuration. It's going to be pretty straightforward. We start with the component. So in this case, we want to create a resource. It could also be an output, it could be a variable, it could be a couple different options. Once we specify what we're going to be creating, we'll specify the provider. So here it's going to be OCI with a resource type of instance, and then we're going to specify a logical resource name. Now this is just how Terraform tracks the resource. That TF instance won't be a display name. It's not going to be anywhere on the resource itself. It's just what Terraform itself will use to create and track the state of that resource. Now, it just so happens I gave the compute resource the same display name, but depending upon the type of resource you're creating, it may or may not include a display name. Block volumes, for example, don't have a display name. Compute resources, however, will have a display name. Another option within Terraform is to use data sources. So think of data sources like a lookup function. I can specify a data source for, in this case, my compute images. And I want to go search. I don't want to hard code the compute image, OCID, in my Terraform config. I just want to go grab the latest version of Oracle Linux 7.6. So by defining the data source, this is basically a lookup. And when I call this in my code, in my Terraform configuration, you can see what's going to happen here is it's going to go back and it's going to pull the latest version of that Oracle Linux 7 image, and then I can use that in the source details definition for my compute instance to simply apply that image that we went and we looked up. So here, all I have to basically code is what OS, what system version, and then Terraform, using the data source functionality, will go out and find the latest image OCID and apply it. This also lends itself to high portability, because again, there's nothing here that's region specific. I can take this code and run it in Phoenix or Ashburn or Tokyo, and it will simply grab the latest local image OCID for that particular environment. Now, as an example here, we're using data sources to look up some other information. Very common use case is to look up availability domains. So when I deploy my code, I want to use whatever AD or set of ADs are available in the particular region. And since the availability domain label is going to have that 4-digit prefix or 4-letter prefix, I would otherwise have to go look that up and hard code it. But using the data source, I can simply say, what ADs do I have available to me in this particular region? And then we can iterate through the one or more availability domains in our code to apply that to various resources. In this case, I'm also looking up some Kubernetes information, so what current versions are available within my Kubernetes service, and then I could use that to make decisions in my code later on. Now we're going to start by building a really quick and easy resource. Let's set up a VCN. There's no dependencies. All we're going to do is specify the resource type, the resource name, CIDR block, DNS label, and the target. This has to go in a compartment, That's about it. This could be the root compartment if we haven't actually created a compartment yet, or it could be a specific compartment if we've built that out already. That's pretty much it. Once we define this, we can move on to the actions available within the Terraform application. First and foremost, we're going to run plan. Terraform, it's kind of like a dry run. What will happen if I actually choose to execute this code? So plan is going to read through all of your Terraform config files. It's going to identify the resources that are set to be created. If you are working with an existing set of infrastructure, so I've already run Terraform several times, I've deployed some infrastructure, plan will tell you what will be added, changed, or deleted. But since we're just creating our first resource, all we're going to see here is the create option. So we'll run Terraform plan, and it's going to come back and say, based on the code you just gave me, we're going to create one virtual cloud network. And here's the details. As a reference, there are the indicators available. So we talked about the resource creation, and you'll see by color code and by label here whether the resource would be destroyed, updated in place, or destroyed and recreated. So certain configuration options, like image ID. If I have a compute resource that's already running and I change the image ID in my Terraform config, that does require the resource to be destroyed and recreated. We can't simply replace the image OCID in place. If the plan comes back and everything looks good, it's time to run apply. So what apply is going to do is actually execute the code. We're going to create, modify, or delete resources as defined in your Terraform configuration based on the existing state of your environment. Again, we just started, so we're not likely to be modifying or deleting anything. But again, further along in the process, if you have already applied your Terraform config and you've gone back to make changes, you might see where there's things being modified or deleted along the way. As an example, when you run Terraform apply, you're going to get a similar output as you saw with Terraform plan. It's going to go through again and say, here's the stuff. Are you sure? Right? It's going to prompt us. Do you really want to do this? And you have to type the word yes before it will complete. If you type Y, if you type anything but the word yes, it simply cancels. So we want to be certain that you really do want to apply this Terraform configuration. At the end, you'll see apply complete, and the number of resources added, changed, or destroyed is in the process. Now, one of the critical facets of Terraform here is the state of the environment. So Terraform will basically track and manage the state of resources created or otherwise affected by Terraform. It creates a local file called TF or Terraform.tf state, and every time a resource is successfully created, the details of that resource are written to the state file. This state file is critical for the maintenance of your environment. If you deploy a bunch of infrastructure with Terraform and then delete or lose that state file, Terraform is going to have a hard time figuring out what it previously created. So the state file is critically important. Always keep that in mind. If we have a quick look here, you can see the state file is stored in JSON, and this is often a source of merge conflicts. So we'll talk a little bit more about this later, but in the previous video, if you watched that first, you saw that there's tools out there like Terraform Cloud, like Oracle Resource Manager, to handle using Terraform in a large enterprise organization with distributed teams and large numbers of individuals working on the infrastructure. Certainly, if it's a small team, if we're working collaboratively, we can just check the state file into source control once we're done, and then have the other team do a git checkout or a git pull to update before they make any changes. But after 2 or 3 people working on the same set of infrastructure, it can become a little tedious. And finally, one of my favorite Terraform actions, the destroy option. This is basically going to obliterate all of the resources that we previously created. So Terraform is going to look at the state file, it's going to look at your configuration, and it's going to go obliterate everything that was previously created. Why is this so cool? Well, Terraform is not just used for static, long-running environments. It can be, and often should be. Terraform is also used for quick hit environments. I want a dev environment for a day. I needed a reporting or a HPC environment for a week to knock out some large computational analytics. Well, with Terraform, I can spin the environment up, I can do my work, and I can tear it back down just as quickly. One of the other permutations here is that you can do a couple things with Terraform. You can target a particular resource. So I want to destroy just a single compute resource. So you can run Terraform destroy, target, and then specify the resource as defined in your configuration, and Terraform will simply go and destroy that one resource. There's also an option, I don't have it here in the slides, but you can actually destroy and preserve. So maybe I created an object storage bucket as part of my Terraform config, and it's full of a bunch of data. I can destroy the entire stack, but I can preserve the object storage bucket. It'll basically set it aside, remove everything else, and then we're done. So you can see here, if we do the destroy, it's going to show us everything that would be deleted as part of the process. So we're going to eliminate 4 resources. And again, it's going to prompt us. Are you sure you want to do that? We'll type yes, and away we go. Now, the outcome of an apply or a destroy really depends on the quality of the code. And one of the key things to understand with Terraform is it doesn't roll back, right? If something fails, Terraform just stops. Everything created at this point will be there. And anything to be created after the point of failure won't exist. So we really have 2 options at this point. We can run destroy, roll everything back, and then fix our code. Or we can just roll forward. So go fix the code, figure out what was broken, and apply again. Anything that already exists, as documented in the state file, will be left alone, right? It's idempotent in that regards. Anything that had not yet been created will simply be provisioned, and essentially we roll forward once we resolve the issue. So we've got a couple of options. It really depends upon the environment. If it's brand new, first time we're provisioning, maybe a rollback is in order. But if it's an existing environment, we're simply modifying. We really don't want to destroy everything and have to start over. It's probably better in that case to fix the code and simply roll forward. Now, Terraform also uses the concept of variables. So, like any good coding language, we're not going to hard code, or we're going to hard code as little as possible. So, with this, we're able to create just basic string variables. So, my availability domain is 1, 2, or 3. I can specify an instance shape or default Oracle Linux version, and then I can simply reference that in my code. We can also create more complex variables like a map variable. And a map variable is going to give us the ability to make some simple decisions at runtime. So I'm going to predefine a set of resources. If dev, then VM standard. If test, then slightly larger instance. If prod, bare metal. At runtime, we're going to do a quick lookup here based on the environment type variable. So this is also a variable here that you specify. We're going to pick from that map. All right, you picked development or dev as part of your provisioning of this Terraform configuration. So we're going to use the VM standard 2.2 image with all of the related resources. So that gives you the ability, some flexibility to kind of predefine a set of parameters, some guardrails, if you will, and then allow your code or define your code in a way that picks from within that predefined list of options. Map variables are also often used for defining image OCID. So if I want to deploy my code across 8 different regions, instead of using the data source that we looked at earlier, I could create a map variable that includes the image OCID that I want to use for each corresponding region. And then depending upon where I deploy my Terraform config, it would simply use the region where it's running to define or to select the appropriate image OCID for that region. Variables, of course, can be assigned. They can be overridden. So you have to define the variable in your code, at least as a placeholder. You can also define a default or just leave it empty. If you leave it empty, you do have to then assign a value at some point if you choose to use that variable in your code. Now, you can also apply a variable at runtime. So if I've coded or if I've set a default of a VM standard 2.2 instance for my shape, and I want to try a 2.4, I can run Terraform apply and then change that variable at runtime. Be very mindful of this, however. If you have a default value set in your TF-vars or in your Terraform config otherwise, applying a variable value at runtime does not store this variable anywhere. It will, in fact, change the shape of your instances to a 2.4, but if you don't go back and modify the default or the variable default value in your code, the next time you run Terraform apply, it will revert back to whatever value is stored in the configuration. So you can see an example here. We're running Terraform plan, we're changing the user, and then the output is simply going to be the modified name. Some additional features we're going to look at here. We can target resources. We briefly touched on that. You can utilize outputs to display or to result specific resource parameters upon completion of the stack creation. We can organize multiple modules into a single stack. So if I have different directories, different sets of Terraform configuration, I can organize that together by defining a high-level stack or high-level configuration that iterates through multiple modules. And of course, if we run into issues where somebody might have created a resource outside of Terraform, we don't want to lose it, we can actually import an existing resource, or a straggler, as I call it, into our Terraform configuration. So the target resource option, you can see here, if we do target at runtime, it's only going to affect that one target that we specified. So if I had a Terraform config with 20 individual OCI or IAM users to create, but I only wanted to create one just to test it, I could run Terraform apply. I could target that specific resource definition, and it would just create that one resource, or change the one resource, or delete the one resource, depending upon whether I'm running plan, apply, or destroy. Outputs are critically important for automation. If I'm provisioning an application with a load balancer, or an autonomous database instance with a public IP address, or even a private IP address, I want to be able to grab that information without having to go into the console, or without having to run additional commands to go look that up. So an output allows me to define a value that includes a resource property. So again, we're using the data source here to go look up the value, the instance vnic private IP and instance vnic public IP for a resource that was created by Terraform. At the end of the command execution, the output will include the private and the public IP address. We can then easily grab that with whatever scripting or automation tool we want to use, plug that into the next series of events, and go do some testing or some additional deployment using something like Ansible to follow up and apply additional configuration or software controls. You can see here, the output we've defined is the user password, and then the result is that user's password. Now, Terraform modules, think of these just like individual collections or packages of configuration that we're going to bundle together. This allows us to be really flexible. So I, as an organization, within my organization, I'm likely to have a standard set of Terraform configuration for networking. Here's the basics, here's the CIDR ranges we use, here's the subnet configuration, the security rules. I want to use the same network configuration every time. Here's a standard database configuration. Anytime my application requires a database, I'm going to use this database module. So we can take all those standard configuration sets and merge them into a single Terraform config by referencing each of them as a module. So you can see here, this is my resource, but instead of calling it a resource and specifying a provider or a configuration, we're simply saying a module, and that module is going to be a collection of Terraform config. The source is the directory, and then we can pass variables to that module. Now the module itself will include all the resource definitions, it will include additional variables, whatever that Terraform config entails, but we treat that just like a sort of recursive or subsequent execution within this sort of parent Terraform configuration. We can also take the output of one module and then pass that as a variable into the next module. So we can kind of create this guided or organized execution of multiple resource sets using Terraform modules. Next up, Terraform taint. So every once in a while, you might have a resource that has become unusable or unavailable. And rather than going in and manually deleting and recreating, you can simply tell Terraform to taint that resource. So we run the command Terraform taint. We specify, in this case, the module, or we can specify one or more specific resources. And all it does is it marks the resource for replacement. Next time I run Terraform apply, Terraform will delete and replace or destroy and recreate that resource because it was previously tainted. You can see here, if I run that command, then a new resource is required. Oftentimes, just replacing a resource in cloud is so much easier than trying to troubleshoot and figure out why it broke. Now, Terraform Provisioners, a little bit different from providers. Provisioners give us the ability to run commands. The example on the screen here you see is the remote exec provisioner. Think of this like a remote SSH command. So after I've deployed my compute resource, I'm going to use a remote exec provisioner to remotely log into the server and run some stuff. I could deploy applications, I could run some scripts. This would be in addition to the cloud init or the bootstrapping script that you might have already applied to the instance. Oftentimes this is used to activate things like Chef or Puppet or Ansible so that we have a configuration management tool on the system that will maintain the environment in an ongoing fashion. As an example here, this is basically used for attaching an iSCSI block volume. So once we create a compute resource, we create the volume, and we create the volume attachment, we have to go to the operating system itself and execute the iSCSI commands to actually mount that volume. All right, so in closing, we're going to do a quick knowledge check just to see how much of that information that you retained. So quickly, what is the best practice recommendation for where to store your infrastructure as code? Is it on a thumb drive? Network file server with tightly controlled LDAP permissions? Private source control repository like Git or Bitbucket? Yeah. Or maybe an Oracle database instance and configure the schema to support JSON, document storage, convert your Terraform configuration to JSON, and insert to the database. You know, I'm going to have to go with C. Keep that source control, keep that in a private source control repository like Git, GitHub, Bitbucket, GitLab, etc. All right, so you've previously deployed a 3-tier web application using Terraform and have just been asked to change the amount of storage allocated to one of your VM database instances. We're going to scale that storage up. After modifying your Terraform file to reflect the requested change, which command would you run to apply that change? Is it Terraform destroy? Maybe if you are looking for a new job. Terraform apply using the plan option. Terraform apply using the target option. Or Terraform taint using the OCI database DB system option. That's right, we're going to use C. So we're going to run Terraform apply, but we're going to target that specific VM database instance. If we run Terraform apply -plan, what that's going to do is it's going to look for a plan that was previously created called scale DB storage. If that plan doesn't exist, the apply will fail. Alternatively, if we run Terraform taint, it's going to mark that database for deletion, which is going to cause us to lose all of our data. So we really don't want to go that route. Answer is C. Use the target option to apply the Terraform configuration, but only to that specific resource that you've changed. All right, folks. Hope you found this informative. Thanks for joining. Take care.